Hello, AP Microeconomics, and welcome back to another video. We're still talking about Unit 3, and today we're going to talk about Module 51. It's a pretty substantial module, and hopefully we'll go through some practice FRQs to help along with this unit. So with that being said, let's go ahead and dig in. So today, Module 51 is about cost-benefit analysis and utility maximization. We're going to maximize utilities when we think of supply and demand, and we think of that downward sloping demand curve. We think about, the law of demand tells us as the price goes down, the quantity demand goes up, and the price goes up, quantity demand it falls. But we also look at this idea of utility, how much satisfaction we're going to get at different levels. And we're going to look at when we have a fixed budget constraint of how much money we actually have, and we want to maximize our satisfaction. So we'll take a look at that idea of maximizing satisfaction. So today we'll describe how consumers make choices on goods and services, explain why consumers' general goal is to maximize utility. We'll look at the law of or the principle of diminishing marginal utility, or I like to say the law of diminishing marginal returns. And then we're going to look at the optimal consumption bundle. So we're looking at like a budget constraint and trying to look at the maximum amount of satisfaction that one can get. So is it possible to prevent wildfires in California forever? Is it possible to ensure that no one ever speeds on the highway? Is it possible for us to create a research station in Mars? Is it possible for us to stop pollution from fossil fuels? Is it possible for us to completely stop illegal immigration? Is it possible for us to make sure everyone in the U.S. has jobs? It is possible, but does the cost, and benefits, when you look at the cost versus the benefit, we're essentially saying the costs of doing this outweighs the benefits. And the question then, why would we do it? And we could argue the moral responsibilities of it, but these things, everything we do, we look at the benefits versus the cost benefit analysis, and we want to make sure that it's sort of like demand and supply. When we want to be at equilibrium, we're allocating our scarce resources efficiently at equilibrium. That's kind of the same thing here when we look at our marginal benefit versus our marginal cost. We want to get the most we can from every dollar. If the cost outweighs the benefit, we're not going to do that. So that's really what we're looking at here. It's not enough that an outcome has benefits. Those benefits have to outweigh the cost. Just because a cup of coffee gives you $1 worth of satisfaction, are you going to spend $3 on something that gives you $1 worth of satisfaction? And obviously not. Though we might have benefits from any one of these things. There's a number of things, like should we build a new bridge, or should we widen roads? There's a cost benefit analysis to all of those. So when we look at these, we have to look at different costs that we have to include in our decision making. So if you go to visit a friend for a week, will you return and you will return on Saturday night? Will you work you can work every day and earn $100 per day. You have 3 flight choices. You have one on Thursday night at $275, one on Friday morning at $300, one on Friday night at $325. So when we think of a cost benefit analysis of this, you might go instantly that the $275 one is cheaper. It is, you're absolutely right. But by leaving Thursday night or even Friday morning, you're giving up $100. Your opportunity cost, you're giving up $100 that you could earn on those days. So realistically, that Thursday night flight is really costing you $375, and that Friday morning flight is really costing you $400. When you think of your opportunity cost of what you're giving you, those foregone wages that you could have earned. So the question would be, which flight would you choose and why? Well, in theory, that Friday night flight would probably be the cheapest because you're not giving up that $100. Now, you also have to think about, if you're there visiting your friend for an additional day, what other additional costs are you going to have to pay? Are you going to eat that? Is your friend going to feed you? Or are you going to pay for things for that additional day visiting your friend? So those are things that you have to consider And you do this all the time. Believe it or not, these things of cost benefit analysis, you look at them all the time in your daily lives. So everything faces trade-offs, right? We have trade-offs and we have opportunity costs, right? Trade-offs, the next best alternative, right? What else could you be doing? Could you be playing a video game or visiting grandma? What could you be doing, right? But your opportunity cost is that value of what you're giving up. So, what are your trade offs of going to college? Well, if I was making $15 an hour, and if you think about the math, $15 an hour, let's say you could make $15 an hour times 40 hours a week, which is $600 a week. That's gross. And then let's say the school year is let's say 36 weeks is well, that might be a little long. Well, let's just say 36 weeks of both first and second semester. Um, then you could have made $21,000 um, at home without going to school. So let's say you're going to the University of Illinois and you pay for tuition and room and board. That's about $34,000. So you'd have to pay out of pocket $34,000 plus giving it up another $21,000. So essentially, your total cost of going to school for 1 year would be over 55, 55,000, around $55,000 to go to school. So are you taking into account the trade-offs, your implicit and explicit costs? And those new words that we haven't talked about since unit one, but the out of pocket costs and then those other costs that you're losing out on, right? So what is your trade-off for going to college is you could work instead. Your opportunity cost is what you're giving up to go to work to college. So we're looking at explicit and implicit costs. So your explicit costs are those traditional out of pocket expenses. So if you're going to go to the movies, the price of the ticket to go to the movies, so let's say the movie costs $10. Your implicit cost would be, well, I could have went to work for 3 hours instead of going to the movies. So if I was making $15 an hour, I could have made $45, right? So you have to take into account if the movie costs $10 plus the 45 you could have earned, the movie really cost you $55 to go to the movies. So that's taking into account both your explicit and implicit cost of going to the movies. So Karen works part time at a local convenience store. She and earns $10 an hour. She wants to spend next Saturday afternoon attending a music concert. The full price of the ticket $75, but she was able to get a discounted ticket for $50 from a friend who purchased it but can't go. If Karen took 4 hours off her job to attend this concert, what is her opportunity cost of going? Well, let's think about it. It's costing her $50 out of her pocket plus the 4 hours she took off of work. So realistically, the concert is costing her $90. That the $40 she would have earned from her job plus the $50 that she spent out of her pocket. So that's implicit and explicit costs. So what did you do yesterday? Think about it. Did you snooze? Did you not snooze? Take a nap. What'd you have for breakfast? Did you have fast food? No breakfast? So all these make decisions, and believe it or not, every time you make these decisions, like who you're going to sit with at lunch if you were at school, what do you have in common with them? Should you study or hang out with your friends or participate in an after-school activity or go get a job? Right? Do you go to bed or do you stay up on watching Netflix or are double tapping pictures on Instagram? So every time you make choices, you have to take this benefit versus the cost. What benefit are you getting? Are you getting some sort of emotional benefit from watching Netflix or hanging out with certain people versus working? Like what is your cost benefit analysis when you're doing anything? And believe it or not, every day you do these. All of these take choices. Even if there isn't money involved, there's still a cost. Like if you're how much sleep are you giving up to stay up all night to watch Netflix? And then you start to rationalize it. Well, I can sleep tomorrow afternoon. I can take a nap tomorrow, or I could sleep in later tomorrow. But then you could be giving up something else. Okay. So In the news, professional line sitters. There came out in November 20th, 2018, that there are people that are willing to wait in line for you. So if you don't want to give up that time, let's say you pay someone $50 to wait in line for you overnight. Well, instead, you could sleep. Well, if you're choosing to sleep and you pay someone else $50, you're saying your sleep is more valuable to you than that $50. Or let's say you could work instead and make hundreds of dollars at that time. So once again, everyone takes a look at their costs and their benefit of saving. Like if you pay someone $50 to wait in line for you, and you're going to save $400 on things that you're going to buy total, then realistically you're saving 350 because you're going to pay someone that 50 that you would have saved, but you're still saving 350, but you're not waiting in line. So those are things that people have to consider. If you go to college, you have to think about, what am I going to give up? Am I going to have good grades, or if I'm going to get enough sleep, or if I'm going to have a social life? Like, if you had to choose two, you'd have to give up something. And what combination of things do you want to have? So we look at the cost benefit analysis. So assume you are buying slices of pizza at a sporting event. Now, this here would be our marginal benefit, meaning how much additional benefit we're getting from each additional pizza. Now, we know law of diminishing marginal returns tells us, as we buy more and more pieces of pizza, the amount of satisfaction or utility that we get gets less and less. So the marginal benefits is the additional benefits for each additional piece of pizza. And we could see that naturally falls because our satisfaction falls. So our total utility is going up, but at a decreasing rate. So we're losing total satisfaction, or we're gaining total satisfaction. We said that, but our marginal satisfaction is getting smaller and smaller. And it looks like a demand curve because that's basically how it works. Okay, so each slice of pizza gives you less and less additional benefits. That's that whole law of diminishing marginal returns. And the same thing, we have marginal costs. So we have to take into account both our implicit and explicit costs. So usually when we think of a supply curve, we think of the producer here. But when we talk about benefits and costs, marginal benefits, marginal costs, the costs, we're looking at individuals' costs of both implicit and explicit costs. The additional money you're going to spend for each additional piece of pizza, right? So that's pretty constant. But that additional time, if you're at a sporting event, that additional time that you keep missing more and more of the game or the sporting event, that time gets bigger and bigger. So that's kind of that implicit cost. So when we think of marginal costs, we think of both implicit and explicit costs. So if we put the two, so once again, this is each additional slice costs more and more since you're missing more and more of the game or the sporting event. So when we put them together, realistically, we should buy 5 pieces of pizza, right? Because we're getting the most out of every dollar that we spend. So that's where we should be at, or at this sporting event. Right? It's just like equilibrium. But once again, this is our personal marginal benefit and our personal marginal cost, right? We want to get the most, our most satisfaction of things. So 5 slices of pizza is our optimal level because that's where marginal cost equals marginal benefits. It's just like supply and demand. This is where we are allocating our resources in the most efficient manner. Now, if we only get 3 pieces, our marginal benefit outweighs our marginal cost. So we'll buy more pizzas, more slices. But if we buy 7 pizzas, our marginal cost is greater than our marginal benefit. So we won't buy, we'll reduce the amount of pieces of pizza. And so that means we'll be at 5, right? Marginal benefit equals marginal cost. Now, if for some reason we don't get right at a number, for a spot like an exact one. Let's say we're at 4.5. Let's say the equilibrium was at 4.5. We couldn't buy 4.5 slices of pizza, so we would just go and buy 4 pieces of pizza, because if we went to 5 pieces of pizza, then our marginal cost would be greater than our marginal benefit. So if we can't be right at a specific number, like 5 pieces of pizza, if we're at like a half a pizza or something like that, we would take the next one below it. So even so, we might have marginal benefits slightly greater than marginal costs in that instant. So we have to look at the marginal analysis and our consumer choices of what we're doing. So everything we talk about marginal analysis, we're talking about the thinking on the margin, making decisions based on increments, how much additional satisfaction. So if we think of Halloween, our favorite candies first out of the bowl, right? After we've gone trick or treating, then we go back and we start to find, well, we start digging through what's going to give us the next greatest satisfaction. So we eat all our favorite candies, then we start picking through them. And then after a couple of weeks, we might be with just leftover candy that we don't really like that much, but we might go, I might eat this one. Or some of you might give it away or throw it away. Okay. So when you decide to go to the mall, you consider the additional benefits and the additional cost, your opportunity cost for going to the mall, right? Once you go to the mall, you continue to use your marginal analysis, how much enjoyment you're getting from shopping, buying food, talking to friends. But then you run into your ex, right? You run into your ex there. So then what happens? Does does the cost of maybe running into your ex outweigh your benefits of continuing to stay there? You might want to leave, right? So, believe it or not, this analysis is something that you're going to look at over and over and over again. So, the point is, you will continue to do something as long as your benefit is greater than your costs. If the cost exceeds your benefit, then obviously you're not going to buy that or do that. So, if we take a look here, we can see how many movies would we watch? Like if let's say the movie, costs us $10. Every time we go to the movie, it costs us $10. But we look at the first time we see the movie, the benefit is $30. The second time we see the movie, it gives us enough enjoyment worth $15. But the third time we see the movie, we only get a benefit of $5. So the question is, would you see the movie three times? Well, no, you wouldn't see it three times. If anything, you would see it twice. The third time, you don't get enough benefits. Your cost outweighs your benefits, so you wouldn't do that. For example, your consumer surplus for the first movie would be $20, right? Because you're willing to pay 30, but you only have to pay 10. For the second time you saw the movie, your consumer surplus would be $5, right? But you wouldn't buy the third movie or go see the third movie because your benefit is less than your cost. So we like to look at marginal utilities, right? Imagine it's really hot day and you're thirsty. Which sip of water has the highest marginal utility? Well, obviously the first one. Why? Because it gives you the greatest amount of satisfaction, but you continue to drink more and more sips. Then somebody turns around and says, "Hey, I'm going to offer you a 12th bottle of water." Well, how much utility does that 12th bottle of water give you uh, right then and there? Well, you might have that water baby, where your belly is bloated, and you might be like, "Oh, if I drink any more water, I'll just throw it up. I can't. My stomach hurts." Right? So every time you continue to take a drink, those first five, six, seven drinks of water, or even the first two or three, if it's really hot, the first two or three bottles of water might give you the greatest satisfaction. But over time, the your marginal satisfaction, your marginal utility will start to fall. So the law of diminishing marginal utility states that as you consume anything, the additional satisfaction that you receive will eventually start to decrease over and over and over again. So the point is you will continue to do something as long as your benefit is greater than your marginal cost. So the more of any good, the less satisfaction you will get from each additional unit that you consume. So let's take a look here. This is the number of pizzas, and we want to look at what is our satisfaction. So here in dollars, we have our total utility, So we're looking at like the first one gives me a total utility of 8. The second one gives me a total utility of 14, which technically means then my marginal utility for the first slice of pizza is 8, but my second slice of pizza only gives me 6. My third piece of pizza only gives me a marginal utility of 5. My fourth piece only gives me a marginal utility of 4. And then it goes on to from 23 to 25. From my fourth to fifth, I only get 2. For my sixth piece, I only get 1 additional marginal utility. For my seventh, I get none. And my eighth piece of pizza, I get a negative utility. That one's going to make me sick and nauseous. So if we want to figure out how many pieces of pizza am I going to buy, I'm going to look at what is my benefit versus my cost. So if we take a look here we see, once again, my benefit. And when we think of the benefit, once again, when we think of the benefit, when we think of from here to here, this is 8, right? From here to here is my 6. From here to here is 5. From here to here is 4. So my marginal benefit is right here. Okay, there's my marginal benefit, right? There's my marginal benefit. So this would be that downward sloping marginal benefit curve we showed. And the marginal cost is straight at $2. Okay, we're just talking about price here, or the explicit costs. So realistically, we would only buy 5 pieces, only 5 pieces, because that's where our marginal benefit equals our marginal cost. So we would buy 5 pizzas. That's the most we would buy. We wouldn't buy a 6 piece because our marginal benefit's only 1, whereas the pizza still costs $2. And this is just explicit cost. We're not taking into account implicit costs here. So you will consume until your marginal benefits equals your marginal cost. That's typically how we think. But what if our marginal utility is a little bit different? For example, if we take a look at this one here, our marginal benefits, we have a little bit different numbers here, and we don't see on this one, the next slide is the same one here, but we could see if the price was $2, we don't see any marginal benefit equaling $2, do we? The closest we get is $3, where $3 is greater than at 5. But if we go to the marginal benefit there is $3, but if we go to the 6 piece, our marginal benefit's only 1, which is less than. So this is like that scenario I talked about earlier, that marginal benefit doesn't ever equal marginal cost, but we're still going to only buy the 5th piece. We're not going to buy the 6th piece because our marginal cost would be greater than our marginal benefit. So we'll get as close to being equal as we can, and we'll never go beyond that where the cost is greater than the benefit. Now let's take a look here at, once again, the behaviors. We're going to look at going to Tahiti on a vacation gives us 3,000 utilities of marginal satisfaction, and going to Chicago gives us a satisfaction of 1,000 utils. So you plan on going to vacation, you want to maximize based on the which is most beneficial for you. So what you do is we're going to take our marginal utility divided by the price. Okay, our marginal utility divided by the price. So we would take the marginal utility of Tahiti over the price of Tahiti, and we would look at what is it per dollar. So this equation right here is what we're doing here, the marginal utility per dollar. So here, if we took 3,000 utilities divided by $3,000, we get 1 utility per dollar. But here we take the marginal utility of 1,000 divided by $500, we get marginal utility of 2 utilities or utils per dollar. So believe it or not, here, though Tahiti might sound really great, we're not going to do that. We're going to take the one that gives us the greatest amount of satisfaction per dollar. So in this example, we would go to Chicago. So we're calculating the marginal utility per dollar, allows you to compare the products of different prices. How much utility do you get versus the dollar? So we're getting the dollar. So this equation, once again, is really important. This idea of marginal utility, I don't know why that keeps doing that, marginal utility over the price. And this gives us the utilities, the marginal utilities per dollar. So we can see how much satisfaction per dollar we're getting for each unit that we are willing to buy. So let's take a look here at this example here. In this example here, we could see that the cost of going to the movies is $10 up here in the left-hand corner, and going on go-karts is $5. Now, we can create a marginal or a budget constraint. In this example, if I only have $40, I can buy, and I'm going to times it $10 times the number of movies. And once again, I don't know why that does that. Plus $5 times the number of, I'll just put K for go-karts, equals $40. That's our budget constraint. So any kind of combination of movies, one, two, three, like we could go to 4 movies, right? 4 movies times 10 is 40. We would go to 0 go-karts. So we're looking at how much satisfaction we're getting. So essentially what we're going to do is we're going to take marginal utility of the uh, uh, movies over the price of movies, and we want it to equal the marginal utility of go-karts over the price of go-karts. We want these numbers to be equal to one another. So this equation right here and this equation, we want them to be equal so that we can find out what's the best combination between the two. So here, this is, we already calculate the marginal utility. Now we could also, sometimes they'll give you total utilities. Like total utilities would be, here it would be 30, then 50, then 60, and then 65 if we added them up. 30 plus 20 is 50, 50 plus 10 is 60, and 5 plus 60 is 65. Here our total utilities would be, once again, 10, then 15, then 17, then 18, right? If we were adding up. But we've already given you the marginal utilities. So if we go ahead and we calculate each of these, we'll get here 30 divided by 10 gives us 3. And then we get here, we get 10 divided by 5 is 2. Now, right now, we know the marginal utility per dollar for movies is giving us a greater satisfaction. So they're not equal. So we're going to go and see another movie, right? So now we can see we're always going to consume, when we're talking about two products, we're always going to consume where marginal utility of movies equals the price of movie or over the price of movies is divided by marginal utility of go-karts over the price of go-karts. So the first one where they're equal is here, 2 and 2, but this is 10 and 20, and then 5 would be $25. But remember, our total that we're willing to spend is $40. So let's go here where 1 and 1 are equal, right? So now where 1 and 1 are equal, let's see, this would be 10, 20, 30, or 10, 20, 30, 35, and 40. So we would, right here, we would go to 3 movies. We would go to 3 movies, and we would go to 2 go-karts, right? We go to the third movie and the second go-kart, okay? That would be the combination that we would do. Now, if we were going to choose, if we had more of a budget constraint, if we had more money, the next thing we would do, if we compare the fourth time going to the movies as a 0.5, but going to this third go-kart was a 0.4, we get more satisfaction per dollar on the fourth movie or than the go-kart. So we would go and do that. So we want to go where we're getting the greatest amount of satisfaction. Okay. So this is where we're going to be here. We're going to go to 3 movies and 2 go-karts. And that's our $40 budget constraint. Okay. Once again, we could have other constraints. Like we could go and see, like if we went to go and go-kart 4 times, because it's cheaper, right? We go to go-karts for 4 times, that'd be $20. That means we can only go to 2 movies. Well, believe it or not, our total satisfaction would be much less. Our total satisfaction would be much less because if we went to 4 go-karts, our total satisfaction, as I said before, would be 18. And then 2 movies, we would be 2 movies, 18. What would that be? 68. But if we went to 3 movies and 2 go-karts, that's the combination that gives us the greatest amount of satisfaction because that would give us a greater amount of total utilities. So 3 movies and 2 go-karts is what we want to do. So how much is the total utility from 3 movies and 2 go-karts? So once again, our total utilities here We would take our total utilities here of three movies. That would be 30, 40, 50, 60 there. And our total utilities from two movies would be another 15, right? So our total satisfaction here would be 75. But what if we went to two movies and four go-karts? Well, two movies, once again, as we said, two movies would be 50, and then four go-karts would be 18. That would only be 68. So you could see we get a greater satisfaction when we use the formula of marginal utility of movies over the price of movies is equal to marginal utility of go-karts over the price of go-karts. All right, so we're going to use that equation, and that's why we'll be here where 1 and 1 equal. Okay, because we're getting the most out of our budget constraint. And our budget constraint here would be 10 times M for movies plus 5 times K equals $40 because we were given $40. Now, what do you think would happen if the price of movies were to go up? If the price of movies would go up to, let's say, $15 or $20, then our marginal utility per dollar would fall. Okay, it would fall. Now, that would probably mean we'd go to less movies. But what if the movie prices went from $10 to $5? Well, then our marginal utility per dollar would double. It would go up, and we would probably maybe go see four movies and no. We wouldn't do any go-karts at all because if we would go to if the movie price fell to $5, if the movie price fell to $5, then our marginal utility here would be per dollar would be 6. Here it would be 4. Here it would be 2, right? And then here it would be 1. So I mean, we would do one. We'd do this for sure, this for sure, this for sure. That's $30. Then the question, then we would probably we'd only have $30, so we would probably we still might do. Yeah, with just a marginal thing of $40, it kind of limits us. We could go ahead and do this extra movie, but we get greater satisfaction from two here. So we would go to the go-karts. It'd still probably be close to the same then. So when we think about utilizing our maximization rule, we want to consume. Consumers' money should be spent so that their marginal utility per dollar is good at as each other. So this is the equation we always want to use. This is the formula whenever we're talking about two products. So it's very similar to when we talk about. Oops, it's very similar to when we talk about. Remember when we talked about production possibility frontiers and we did like this? And we said this is the most you can produce. Well, now this is the same as the budget constraint. If we had product Y and product X, given a certain amount of money, this is the combination of things that we could buy, right? But depending on our budget constraint. Now, if we get more money, this would shift to the right. If we had less money, it would shift to the left. If the cost of X diminished, we would probably see it go like this, because if the price fell of good X, we would be able to buy more of good X. So it's very similar to the production possibility frontiers, but we're looking at how much we can consume. Okay. And believe it or not, you do this all the time. But this is how we're going to calculate it. We're gonna look at if we have two products. So to maximize utility, a consumer with a fixed budget will purchase quantities of goods that the ratio of the marginal utility is good as D, prices are equal. Okay. So that ratio has to be equal. So that formula that we looked at here, they have to be equal. Okay. Next one says the same thing here. It's to suppose that the consumer purchases two goods, X and Y, and the marginal utility of X is marginal utility X, and the total utility of X is TU X, and the marginal utility of Y is MY or MUY, and the total utility is of Y is TUY. If the prices of X and Y are PX and PY respectively, which of the following expressions defines equilibrium? Well, here the answer would be D. They gave you this extra, they gave you this little bit right here and this little bit right here to kind of throw you off, but those aren't even used in calculating with our budget constraint and our marginal benefits of two products. So normally I have a video in class we'd look at. Let's take a look here. Okay, let's take a look at this equation right here, or this problem here. It says um, the student has $10 to spend on all its pizzas and pens. If the pizza, the price of the unit of pizza is $2, so I'm going to write up here the price of the pizza is $2, and the price of pens are $1. Price of pens are $1. Okay, and which of the following would we do? How many would we purchase? So we would first, luckily here, they gave us the marginal utilities already, didn't they? They gave us the marginal, they didn't give us total. Many times they will give you total utilities and then you have to calculate the marginal utility. But in this example, from the 2010 AP exam, they gave you the marginal utilities already, which they kind of diminish it or takes away one step that you don't have to do, because a lot of times they'll give you total and then you'll have to calculate the marginal. But once again, we have to do marginal utility of pizza, or I'll put Z for that, over the price of pizza. And then over here, I'll put marginal utility of pens over the price of pens. So here for pizza, 20 divided by 2 is 10. 18 divided by 2 is 9. And then we have 8, and then 7, and 6, and 5, and 4.5, and 4. Over here, it's just divided by 1. So marginal utility divided by the price. So it would be 8, 7, 6, 5, 4, 3, 2, 1. And it says our budget constraint here is $10. So our budget constraint equation would be $2. Would be $2 times the number of pizzas plus $1 times the number of pens equals $10. That's our budget constraint. So essentially this line, so if I put pizzas up here and pens down here for $10, how many pizzas can I buy? Well, if the pizzas are $2, I can only buy 5. So there'd be 5 pizzas here. How many pens can I buy? I could buy 10. So therefore I can draw, there's my budget constraint line. So there's different combinations. So I can get one piece of pizza, which is $2, and then I can get 6 pens. I could buy 2 pieces of pizza, that's $4. Or I'm sorry, if I buy one piece of pizza, I can buy, that's $2, I can get 8 pens. If I buy 2 pieces of pizza, that's $4, so I can buy 6 pens. If I buy 3 pieces of pizza, right? If I buy 3 pieces of pizza, that's $6, so I can only get 4 pens. I can buy 4 pieces of pizza, which is $8. I can only buy 2 pens then. So those are the different combinations. But we want to know, where is my greatest satisfaction? Where do I get? Well, I'm definitely going to get this first piece of pizza. I'm going to get this second piece of pizza. Now let's look. Third piece of pizza and the first pen are both 8 and 8. Well, they're both 8 and 8. So the question will be, let's see, 2, 4, 6, 7. That's only $7. So, but then I look at 7 and 7, right? So now it's 2, 4, 6, $8 is here plus $2 here. Well, that's what I'm going to do. I'm going to get 4 pieces of pizza and 2 pens, which is the answer B. Okay. Now it says if the student purchases 2 units of pizza and 2 units of pens, the total utility will be, well, if they do that, they're buying inside. If they are only going to buy 2 units of pizza and 2 units of pen, they're actually inside this. So they're not maximizing their utilities. But what is the utilities? Well, let's look here. 2 pieces of pizza. Well, that would mean right here, 2 pieces of pizza. That would be 20 plus 18, which is 38, plus 2 pens, which is 15, right? So therefore, what is that? 8 and 5 is 13. So that would be 53 total utilities. So that should be answer E. Okay. Let's take a look at this next one here. Let's take a look at this next one. So this one says if we're going to do apples and oranges, and this is an FRQ. The answers are in the next couple slides, but let's take a look here. It says apples are $1 a piece. So I'll put $1 here, and oranges are $2 a piece. Okay. And here they have the total utility, and they said that the budget constraint, we have a whopping $7. So our budget constraint is 1A, right? Plus, I'm not going to use or I'm going to use R for oranges because if I put zero O, it'll look like zero. So I'm going to put then $2 times the number of oranges equals $7. That's my budget constraint. Okay. And therefore, if I know if I have $7, if I put apples here and oranges here, if I have $7, I can get 7 apples, right? I could, but oranges I can only get what is that? They're $2 a piece, so I can only get 3 oranges. So that would be 3 right here, and that would be my budget constraint right there, given this information. So it says use the concepts of marginal utility spend and identify the combination of apples and oranges the consumer will purchase and explain your reasoning. So we'd have to calculate, I'll go to the left here, I'll calculate. So they gave us total utility. So the marginal utility would be 20, 15, 10, 5, and 2, right? It's the difference here. The marginal utilities here would be 30, 20, 15, 10, and 5. Okay. Then it says now calculate and I'll choose a different color here to write with. It says now calculate, so I have to calculate marginal utility per dollar. So let me find, there we are. So then I'm going to calculate the marginal utility per dollar for each of them, marginal utility per dollar. So here it would be the 20 divided by 1, which is 20, and 15, and 10, and 5, and 2, right? Because this is divided by $1. But over here, you're going to divide it by 2. So here, 30 divided by 2, because we said oranges are $2. So this would be 15, 10, 7.5, 5, and 2.5. So where should we be to get the most out of our $7? Well, we're definitely going to buy this first apple. And then if we buy the second apple, so we're 15 and 15 here, the first orange and the second apple, but that's only $2, 3, that's $4. So let's look at 10 and 10. Well, here we go. $1, $2, $3 here, and then 2, 4 at $7 right there. So we're going to buy 3 apples and 2 oranges, and that will equal our $7. Okay. Oh, and I forgot. I didn't, because 3 apples, because each apple's $1, so that'd be $3, and then this would be $4 because each orange is $2, and that would be our $7. Okay, so that would be why, because that's where marginal utility. So you'd have to state where the marginal utility here is the same. Okay. Then it says, with the prices of apples and oranges remaining constant, assume that the consumer's income increases to $12. So now at $12, now we're going to be able to buy 12 apples out here, and then $12, we could buy a maximum of 6 oranges. So now here's our new budget constraint. It's out there further because we have more money. We went from 7 to 12. So what combination would we be able to get now? Well, let's look. After we are at 10 and 10, we're definitely going to buy this fourth orange. Now the question is, are we going to buy here? Let's go 5 and 5, or marginal utility per dollar 5 and 5. So we would buy right here 4 apples and 4 oranges, because 4 oranges would be $8 plus 4 apples, which would be then $4. So we would get 4 apples and 4 oranges would give us the amount that we would do. And then it says, what would be the total utility that you would receive at that point, of what we calculated right here. So here, our total utility here for apples was 50, plus our total utility of the fourth orange is 75. So our total utility of happiness would be 125. Then it says, with income of $12, assume that the price of oranges increased to $4. Ooh, so let's try a different color here. Let's go with purple. So now, if the oranges double in price, now we're still here at 12, but now at $4, and how many? And our budget constraint is only at $12. So now we can only get three. So, oop, that's not very good. But it would be, we can maximum either 3 apples or 12, or I'm sorry, either 3 oranges or 12 apples. Okay. So let's take a look here. If we double the price here, so if we go 30, we still at 30. So I'll calculate the new marginal utility per dollar, and now it's at $4. So that would be what, 7.55. $4, what would that be? 3.5. And then 10 would be 2.5, and then that would be 1.25. So now it says, what combination could we purchase now? Well, now we would go 20, 20, 10. Then we would get one here. We would do a combination here. For this one, we would do a combination of four apples and 2 oranges, because the oranges are $4 a piece, right? So that would be the new combination of what we would get, because this would equal to $12, because 4 apples is $4 and 2 oranges are $8. So $8 plus $4 is $12. Now, what would be the total consumption, or the total, because this is what's the total utility for doing this? That would be, let's see, that would be 50 oranges plus, what did we say, 4 apples? 4 apples is 50. So that would be, then our total utility would fall down to 100 because of the price going up. Okay. So that's an FRQ, and the answers are in your notes here. Okay. This is another good one here. Let's take a look at this one here. This says you have a fixed budget up here of $20, and you can buy either X or Y. X is $4 and Y is $2. So your budget constraint would be 4 times X plus 2 times Y equals $20. Okay. And this, once again, has our total benefits on both sides. So we know we're going to have to figure out our marginal utility, and then we'll have to figure out our marginal utility per dollar. We'll have to figure out marginal utility and marginal utility per dollar. Okay. And we, once again, we know X is, what do we say? X was $4 and Y was $2, right? Okay. So it says, what is Martha's marginal benefit of the fifth unit of X? Well, the fifth unit of X, her marginal utility here is just 1, right? It's just $1. Her marginal utility for the fifth is $1. So here we can calculate the marginal utility from 40 to 41. It's just 1, right? It says then Martha's is currently consuming 4 units of X and 2 units of Y. She's currently here and here, right? Using marginal analysis to explain why this combination is not her optimal, okay? So she's at 4 of X and 2 of Y, and why that's not very good, right? So we'd have to calculate the marginal utility. So here, marginal utility here is 16. Marginal utility here would then be 12, then 8, and then 4. And the marginal utility over here would be 10, 8, 6, 4, and 2. Then we'd have to calculate it per dollar. So 16 divided by 4 is 4. 12 divided by 4 is 3. 4 divided by 4, or 8 divided by 4 is 2. 4 divided by 4 is 1. 1 divided by 4 is 0.25. Then over here, we would take 10 divided by 2 is 5. 8 divided by 2 is 4. 6 divided by 2 is 3. 4 divided by 2 is 2. And 2 divided by 2 is 1. So where should she be? Well, we know that she's going to buy this first one, right? She's going to buy this first one here, 5. Then she's the second, and her then she'll buy the X and one more of Y, but that's still not up to our $20 because these are 2, 4, and $8. So then let's look at 3 and 3. Well, here we go. Here's 4, 8, 10, 12, 14. No, that's still, she could go, let's try 2 and 2. So let's look at 2 and 2 here. So here we have 3 items at $4 a piece. So this would be $12 here. And then, so that would be $12 there. And then 2, 4, 6, 8. So 12 plus 8 is 20. So she would be here and here. So she would buy the third of X and a 4 of Y would maximize. So if she was buying 4 units of X and 2 units of Y, she's actually not maximizing her marginal utility. Her marginal utility should be her optimal right here. Her optimal should be 3 of X and 4 of Y. That would be where she'd maximize her thing. If she was at 4 of X and 2 of Y, she would actually be, if we think of our budget constraint, she would be inside here somewhere. She wouldn't be maximizing her utilities at that point. Okay. Now, the next one says indicate whether the following will cause the optimal quantity of Y to increase, decrease, or stay the same. So if the price of good Y doubles, so if the price of good Y doubles, she's going to decrease the amount of products that she buys because her marginal benefits per dollar will fall. What if her income falls with no changes to the prices? Well, both things she's going to buy less of. And then if Martha's income doubles and the prices stay both doubled, then it would stay the exact same. It would stay the same. Okay. And we'll see those answers are also too in your notes. So there they are right there. All right. So this one is also one, and I already have the answers here on the bottom, so you could pause it and take a look here. These are the answers to the 2 questions. So you can look at Sasha's utility. So if you want to pause it, take a look. The answers are underneath there. So I have, once again, videos that we normally show in class, but we're not looking at it right now. So once again, when we think of the important concepts, once again, we're looking at utilities, how much satisfaction you're getting from a given product. We're looking at your total satisfaction and then your marginal satisfaction, the additional satisfaction you get for each additional price or product. So if we look at here, the kind of the production function or the consumption function, I should say here, we could see that here's our total utilities. They keep going up, but we can see that our marginal utilities keep falling because of law of diminishing marginal return. So we could see essentially here, where is she getting the greatest amount of marginal satisfaction? Right here at 8 units. And you can see at 8 units is 64 here. Okay. So that would be like her greatest satisfaction. But you can see it's increasing at a decreasing rate. It's increasing at a decreasing rate, her marginal satisfaction. So if Casey's here's total utility depends on her consumption of fried clams, well, what if the question becomes she should have the greatest utility is at 8 clams. She's getting 64 utilities, and we understand that she wants to get the most she can from her dollars. But what if she wants to buy 2 things, right? We understand the law of diminishing marginal returns is her satisfaction continues to fall of just buying clams. So will she want, Is there something else that may give her a greater satisfaction than that diminishing fall of clams? So if we give Casey a budget constraint and tell her that you can make a combination, you can buy two things and you want to maximize your satisfaction, we're going to create a budget. We're going to create a budget constraint. So here she can either buy clams or potatoes. So if we look here at quantity at bundle A here, she's buying just potatoes. And if we look at F, which is down here, she's buying just clams. So this is like sort of like the production possibility that we learned in the unit one, but this is her consumption, her budget line, how much she can afford. Now the question will be, these are all different combinations of things that she can get. So we could say 10 is her like her y-intercept and 5 is her x-intercept. And we can calculate, these different budget, at bundle A, B, C, D, E, or F. Where is she getting the greatest amount of satisfaction at each of these? So if we turn around and we look at her satisfaction, and we can look at her total utilities here from each of these things, right? So clams, we can see her first clam, she gets 15. After having two, she has 25 utilities, 3, 31, 4, 34, and 5, 35. We can see that her marginal utility is getting smaller. The same here with potatoes. So what combination of clams and potatoes will she get, given her budget constraint, that will give her the maximum satisfaction? So we're going to give her a budget constraint, right? We're giving her a limited amount that she can buy. So in theory, if we look here, we look at her satisfaction here. We can look at the amount of satisfaction she's getting at different poundages. So at those 5 bundles that we showed before, if she bought all of potatoes and 0 clams, we could see her total utility is 56 because we would just add this. But at bundle B, where she's getting 1 clam and 8 pounds of potatoes, 15 plus 53 is 68. And then at C, we could see 2 clams, 2 pounds of clams, she's getting 25 utilities of happiness. And at 6 pounds of potatoes, she's getting 47. And we can see her total utilities between the two is at 72. So her budget constraint says that she should be eating 2 pounds of clams and 4 pounds of potatoes. So here is the idea of what she's producing. So we can graph her total amount of satisfaction here. So this is the amount of products that she's buying, the different combinations of total utilities. And you can see right here, this right here at C is the point. Now, every one of these, A, B, C, D, E, and F, are maximizing her budget constraint. But where on her budget constraint is she maximizing her satisfaction? And she's maximizing her satisfaction at C right here, as I had shown earlier in those FRQ examples. Okay. So once again, when we're looking at finding out the satisfaction, we're looking at marginal utility of, let's say, clams over the price of clams has to be equal to the marginal utility of potatoes over the price of potatoes. That's what she wants to do. She wants to make those equal. So we want to know per dollar how much satisfaction we're getting. So again, if we take a look here, we look at, they've done the math here for us, right? We figured out the marginal utilities here, right? So we have total utilities here. Here's the marginal utilities. And now this is the marginal utilities per dollar. So this is $4 per clam or per pound. Once again, here is total utility. Here is the marginal utility. And this is marginal utility per dollar at $2 a clam. Okay. And remember, I believe we said that, now this won't be exact, but we said that she was going to be at 2 clams here, which was a marginal utility of $1.05 or 1.5. And then we said 6, which gave her 1.75. They're not exact, but that's the point where we're going to get the greatest amount of satisfaction that she's going to have. Okay. So this is it right here. This is that combination of the two that she's going to have. Once again, this is those equations of marginal utility of clams per the price of clams and the marginal utility of potatoes over the price of potatoes. And we can see she's going to be here at 2 clams and 6 potatoes. They did this a little different than the way we showed it before on the FRQ. Okay, so once again, it's a matter of calculating the budget constraint. You want to be able to calculate the budget constraint. You want to know how many utilities you have. You want to come up with a budget constraint, and you want to try to earn the greatest amount of satisfaction given your budget constraint. And once again, we use marginal utility of one product of X over the price of X has to equal marginal utility of Y over the price of Y. Okay, and this is where we're going to get the maximum. This equation is going to get us the maximum amount. Now, let's say the marginal utility of X is over the price of X is 3. Let's say that's 3, and the marginal utility over the price of Y is 1. All right, and you're here. Well, if you're here, if you end up with a 3 and a 1, they're not equal. This means that you're going to have to buy more of X and less of Y. Okay, so you're getting greater satisfaction with Y. So you're going to buy, or I'm sorry, with X. So you're going to buy one more of X and see where that puts you of Y. Because remember, if we follow that budget constraint here, and we have X and Y, if we're right here and we're going to buy one more of X, that means we have to give up, or I'm sorry, if we're here and we're going to buy one more of X and go to here, we're going to have to give up, wait, this is Y up here. My Y doesn't look very good. I don't know why my Y doesn't look very good. My Y. For me to buy more X, I have to give up Y, okay, on my budget constraint. So if my marginal utility per dollar for X is greater than my marginal utility of Y, then I'm going to buy more of X and less of Y. Now, if it was opposite, if I had like Y, my marginal utility per dollar for Y was 5 and my marginal utility of X was 3, then I would buy more Y and less of X because I want them to eventually equal one another. Okay. So this is quite a bit of information. Hopefully this is helpful. So until next time, have a great day.